So, job scheduling. I think the name speaks for itself. In the context of operating systems, job scheduling is about scheduling which job is executed at what point. But to understand the concept a little bit better, there are two important words to understand first. And that is concurrency and parallelism. So these are two different concepts. And what they mean is, in concurrency, you will schedule jobs in a way that makes it seem as if they were running at the same time. But that is not the case. So for example, you would start job 1, then before that finishes, you would jump to job 3, to job 2, to job 3, to job 1 again, and you would always jump back and forth in such a high pace that for the human, who is much slower than a computer, it would seem as if they were executed at the same time. But that's just an illusion. Whereas in parallelism, you would actually run job 1 and job 2 and job 3 at the same time. But now the thing is, one processor core can always only do one thing. So for parallelism, you need multiple cores, either a multi-core processor or multiple processors, or both. Then you can run several processes or jobs at the same time. Now the problem is, even if you have a quad-core or an octa-core processor, that would still mean that you can only run 4 or 8 processes at the same time. So in modern machines, you combine these both methods. So if you imagine your processor like this with its multiple cores, let's for simplicity just say you have a quad-core processor. Then you would have parallelism for the whole processor. Right? But inside of each single core, you would use concurrency to run even more processes, at least seemingly at the same time. So you can run more than 4 processes here. I mean, if you've ever looked into your task manager, you figured that there are many, many more processes running at the same time in modern day systems. So we have to use concurrency. Okay. Now, there are different ways to schedule that. Remember, you have to jump back and forth between processes. But how do you decide what process will start first and then what comes next, what has to go out, and so far and so on and so forth? So there are different approaches, and they are mainly divided into 2 groups. So there are preemptive scheduling algorithms, and there are non-preemptive ones. Okay, probably for those who grew up with English, it's easier to understand, but for everybody whose first language is not English, like myself, what preemptive means in this context is that even though a job is not finished yet, it can be halted and another job is activated, runs for a certain time, and then this one can also be halted before it is finished. So that it is more fair for other jobs because no job has to wait too long. They can start their execution at an earlier point. Whereas non-preemptive means that as soon as you start a process, or a task rather, you have to finish that one before you can start the next one. And now we could speculate about which one is better, but I think it will become more clear with the examples that will follow. But let me name a few versions or a few approaches first. So among the most well-known ones are, for example, first come, first serve. which means the process that comes into the waiting line first will also run first. And this one is handled as a non-preemptive algorithm. So that means a job comes into the queue, is executed, and as soon as it is finished, the next job that came into the queue will be executed. Then you have the preemptive shortest job first. So that means the job in the queue that needs the least amount of time until it is finished will be executed first, of course, among the jobs that are already in the queue. So if there's only one task in the queue, this will, of course, be executed no matter how long it takes. But as soon as the second task comes into the queue, the system checks if the second task needs less time to be executed than the one that is already in execution. And if that is the case, the first one will be halted and the second one will be started. Now, if a third one comes into the list or into the queue, that is again shorter than the second one, this will be executed next. And then after another, all the jobs that have been started will always be checked if they need the least amount of time until they are finished from the current point on. And then that one will be executed until everything is done. So that would be preemptive shortest job first, because it allows that a job that is in execution right now is halted and another one is started. Then we have another preemptive one, which would be preemptive priority. So usually a job also has a priority, and the way it works here is pretty much the same as in shortest job first, but with the difference that you would value the job, or that you would decide which job is executed next based on the priority, not on how long it will take until it is finished. And the difference is also that in shortest job first, the job that is the shortest might change, because when it is executed for a certain amount of time, the remaining time is less than before, whereas the priority usually doesn't change. But still, a job can be halted when there is a new job coming into the queue that has a higher priority. And last but not least, a very often used algorithm would be the round robin, which is in its nature a preemptive algorithm, because the way it works is that you have a certain amount of time that every process gets until it is halted and another process starts. And that's called quantums. A quantum is just your time unit. And let's say you have, for example, the quantum 3. That's just an information that you need when you perform the round robin. Without this information, you either have to decide yourself or you can't perform that one. So that would mean that job 1 gets 3 quantums of time, and no matter if it is finished then or not, the second process will start. Also gets 3 quantums of time, and so on. The only way this can be different is when a job only has 2 quantums left, for example. Then, of course, you wouldn't wait until 3 quantums are over, but as soon as the job is done, the next job comes in. So this is just a very rough explanation, but we will see a few more details in the examples, and then I think it will also become very easy to understand. Okay, so let's say we are presented with the following table, and then we are asked to schedule the jobs using the first come, first serve. So what do we see here? We have our process number. In this case, it's ordered from 1 to 4, but that does not necessarily have to be the case. They can appear in a different order, but here we are lucky that the first process is also the one arriving first. Then we have a burst time, which is essentially just the time in quantums, if you want so, that it takes until the process is finished. So we can see process 3 finishes in the shortest time, and process 4 is the biggest one and will take the most time. Then we have the arrival time, which is just at which point the process comes into the queue, because there are new processes coming up all the time, and this is where they arrive. And then we have the priority, which just means how important the task is. Now, we can already see that not everything in this table is important for the first come, first serve. At least not firsthand, but we get into that later. Because the priority, for example, plays no role. The burst time only plays a role in terms of how much time we schedule, but not for which process starts first. But still we need that one. The priority could come into play, for example, if 2 processes arrive at the exact same time, because then you need a secondary algorithm which allows you to decide between 2 tasks that would otherwise have the exact same timing. As you can't run them at the same time, you need some secondary option to decide that. So for that you could use priority, for example, or the burst time, that depends. Okay, so let's try to make a nice timeline of which process would run at what point. So this is our timeline. And now we have to decide what process do we start with. Because we have first come, first serve. We start with the process that arrives first, and that is in this table process 1. How long does process long take? 5 time units. So process 1 would run from 0 to 5, and we can draw that in here. Then the second process arrives at 2, but at 2, well, process 1 is still running, so we can first start at 5. And from there on, it takes 3 time units until it finishes. So it goes from 5 to 8 for process 2. At the same time, or still when process 1 was still in execution, but after process 2, process 3 arrived. So that is next, and it has a burst time of 2 time units. So it goes until timestamp 10. And then we only have process 4 left, which also arrived meanwhile. And this goes from 10 to 18, which shows us that we didn't make a mistake. Or at least we have good chances of not making a mistake when the times you are drawing into your timeline add up to the overall time that all your burst times together add up to. So this is a very simple example of job scheduling. I will leave it with this for this video, because this is just to get a general idea of how that works. But there will be a follow-up video, or maybe even multiple, for other job scheduling algorithms that are a little bit more complex. But I think this example was already good to give an idea of what job scheduling is and what it is used for and how it basically works. I hope it helps.